I can invite people in. I just don't know how to do that.
Oh, you could hit. Okay, so if you mouse over to the left side, and then it opens the menu, and then you see that little icon, like a symbolized a person, and it has a plus sign. I think
Hmm.
that's when you click at that, and then add people to.
Okay.
It's on
Oh,
top.
okay. I did
Yeah.
that with everybody.
Oh,
Okay.
okay.
Let's see. If I refresh this page here, I'm still figuring out Hangouts on Live right now, so I haven't actually seen how this works. I think
Mm-hmm.
people can join in. Okay. So I think all any. Let me see. I'm gonna do this. I'm gonna go open up my other computer that I have here and try to join and see what happens.
Okay. Do you have a different ID?
Yes.
Okay.
That'd be weird. Two people with the same name join.
Yeah. That sometimes could happen too. Pretty weird.
Oh, come on. The mouse not working.
So where
Um,
are you, Jeremy, exactly?
I'm in
Trying to
Santa
figure out
Clara.
how far is it from Orange County?
Okay. It's I'll just put up the maps here.
I was just trying to see if you and I
It's
can get to
about
meet up together
six and a
sometime.
half hours away, I think. 6.5 to 7 hours.
Oh, that's a long way.
It's a long way.
It's not possible then.
Yeah, it's a bit hard.
Yeah. Oh, Jen is here.
Oh yeah, it actually worked. Okay.
Okay.
Cool.
Hey, Joe. I'll be right back.
Hey,
How are
Linda.
you, Jen?
All right. I didn't really go through this too much, but I think it's going to be easy enough where we can just plug it into IRB.
Man, you didn't go through enough. I went through a lot.
You went through the whole thing?
Yeah,
It's not
just
Oh.
working.
kidding.
Oh my
Just
gosh.
want to mess with you.
Actually, nothing's working. Fuck. Is that a Starbucks?
Yeah.
Oh,
Nice.
okay.
I'm
Cool.
supposed to have like some family come over today or something, so I was like, I probably should leave.
Yeah.
Linha, what part of Orange County are you in?
Garden Grove.
Hmm.
If you just type in like, yeah, I'm right at the center of the city of Garden Grove. So if you use the zip code, it's 92843.
Hmm.
Yeah,
Oh, okay. Disneyland's not that far away. Got it.
yeah.
Oh, okay. It's right below Anaheim. Got it.
Hey, Jeremy, are we, I saw there was a couple other people on the email. Are we expecting them?
Expecting, but I'm not entirely sure if they're gonna come.
Okay.
So, um, let's just start at 11, and then
Okay.
once people come in,
Yes.
because some of the new people we should probably introduce. I don't know.
Okay. So, hey, everyone. Hey, Joe.
Hey, Joe.
Hello, how are you?
All right. So, pretty much all you guys got the email on like the Levenshtein distance formula.
Yep.
Yeah.
Oh, Merrick.
Oh, cool.
Hey, Merrick. Okay. So,
Merrick. Oh, he left.
okay. All right. Well, basically, let me just give you the rationale behind it.
Okay.
So Levenshtein distance formula basically, like I said, it tells you the distance between two words. And I thought that this would be a good thing to go over because it's something that you could see like in a coding challenge, that like in an interview. So really what it has applications for is like making an autocorrect. So like for instance, if you search on Google and you type in the wrong word, like you just spell it incorrectly, Google will give you a suggestion saying like, did you mean this? And so I'm pretty sure they probably use like the Levenshtein formula in order to make those suggestions. So that's where this might come. Hey,
Hi, Eric.
Hey, Mark.
All right, so okay, cool.
Sorry, Merrick. Jen was just explaining what the, how do you say it, Levenshtein distance formula works, or not works, but what the top level picture.
So,
oh, sorry. Go ahead.
So Merrick, basically what we're saying is that the Levenshtein formula is a formula that lets you take two strings and then you compare those two strings and see how close they are to each other. And so it's something that it's used like for autocorrects. So like for instance, if you type in the word spelled incorrectly on Google, it'll give you a suggestion. And then, so I'm pretty sure like the Levenshtein formula has something to do with that.
Mm-hmm.
So, and then the reason we're going over this is because you'll probably see this like in interviews as like a coding challenge.
Oh, nice.
All right, so I think maybe I should like share my screen.
Yeah, that sounds good. While Jen's doing that, I'm going to just say that because this is on Hangouts on air, I'm able to record this, so if you can't make any of the sessions, they're going to be on YouTube later.
Okay.
1 second. Never mind. I'm just going to share my screen and then plug it into IRB.
Do you need any help?
No, my computer's just acting a little bit slow.
Oh, okay.
Should be working right now. So, can you guys see my screen now?
Mm-hmm.
Yep.
Yeah.
Okay. All right. Okay. So basically, here's the method that I showed to you guys. First and second just represent the first and second word. So let's, for this purpose, let's assume like the first word is like a user input. So let's just say first equals user input, and then the second one is like the word in a dictionary. Okay, so I don't want to like overpower this, so I'll let you guys like drive this. So like, can someone start by talking about what's on line 3? Or trying to figure it out, I guess.
So we're making a single row array from 0 to the length of the first word. Wait.
Sure. So what if we do this in IRB and let's choose the first word to be misspelled word. So the first word is W-I-R-D. And then the second one is spelled correctly, so it's word. Let's take If it's an IV. Alright, and let's say that matrix.
Jen, we can't see your terminal.
Oh, can you see it now?
Yep.
Okay. Okay, so how long is the length of the first word?
That's 4.
4, right. So plug in 4. And let's make this. So that's what we have in the matrix. Is a two-dimensional array. And then we can do the same thing, but with the correct word, which would just be, again, the same array, except we're going to start from 1 this time. So I guess I should. Sorry, I'm not good at like presenting this kind of stuff.
Well, it's okay. You're
Right,
just
you guys
trying
pretty much know, right?
What are
Well,
you
I'm
up to,
sorry, I
Jeremy?
don't know
Looks
what.
kind of funny. It's only your back.
Uh-oh.
Uh-oh, what happened?
Jeremy ended the presentation.
Jeremy's back.
Sorry. Here we go.
Oh, okay.
Whoa. Okay, that does not work.
Yeah.
Okay, so I'll stop presenting.
What happened?
I got it.
What happened?
That happens if I press
The screen share.
Right. Not the screen share. Oh. Wait. Can you go back to the Sublime?
Okay, I'm in Sublime.
Okay. So, yeah, line 4 I think we get. So let's just move on to line 5 then.
Sure. Okay, so with line 5, it's the same sort of thing, right? You start at 1, and then you go up to the length of the second word, which is 4. It's just like this, 1 to 4. But you know that that's going to be arranged. So then we want to call each on that range. So I'll let you guys take it from here.
From 1 to 4, and then, yeah.
All right, so then what do we think is happening here on line 7, and why?
Well, okay, so let's break this down here. So J is another matrix of the number range between 1 to 4. This is 0 plus first.length. I'm actually slightly confused at adding matrices together. So do they add the element together, or do they add append elements?
So I think what they do is they add the matrices together. So for instance, if we start with J starting from 1, and here I guess I should do it in IRB. So if J is 1, we have basically 1 plus 0. Let's just see what happens there. And you get an array of 1 and 0. So then what else they do is they multiply that by the length of the first letter, or the first word, right? And you end up with this.
Oh.
Yeah, you do. So why do we think that happened?
Oh, wait. Gotta see that one again.
Do you want me to do it?
Wow. Yeah, I saw it now.
Okay.
Wow.
Yeah.
Well, okay, so if you have a mismatch, for example, like the two words aren't the same length, then you have more possibilities that you have to add letters to the chain of words, right? So say you had like the word word and then the word wordy or something. There's an extra Y in there, so there has to be an extra. I don't know what I'm trying to say here, but there has to be something with a length mismatch.
Okay. Right, because ultimately we're trying to figure out what the distance is between the two words. So if that makes sense, I don't know. Okay, so
what doesn't make sense to me still is the matrix itself. Like, why do we use a matrix to determine the path or the distance?
does anyone? Does anyone have any suggestions? I don't want to overpower this.
Also, Joe, is your microphone on? Because I couldn't hear you earlier.
Yeah, we're not getting it.
Okay.
So, quickly, I don't know why we're using the matrix, but I'm sure as we continue, we'll probably figure that out.
Okay, I guess we can keep on going and figure out the matrix outputs, and then go from there.
Okay, so I'm going to make a quick note so that we can see. Are you recording this, Jeremy?
Yep, this is being recorded.
Yeah, it's pretty jumpy.
All right, I'll send you a note later.
Okay.
All right, so this is what we got. All right, so let's skip down to line 11.
Oh, okay. Sorry, I was still looking at line 7. Order of operations notes that what's going to be multiplied are the zeros first, and then you add on J at the beginning.
Yep.
Okay.
Okay, so basically, starting at line 11, we know that we have like nested loops. So someone just shout out stuff and we can start talking through it.
Sorry. Well, I'll jump in then. So we're iterating through the second word and the first word. And what we're actually doing is we're going through the matrix in a certain order. So, let's see. I'm not entirely sure what that order is. Let's see. Oh man, there's a lot of stuff here.
Yeah. What if we started from inside and then worked our way out?
Okay.
So like looking at line 13, for instance.
So I is the coordinate for second length, and J is the coordinate for the first length. Okay.
Can you hear me now?
Yay, we can hear him.
Okay. Yeah, so I and J is basically the letter that corresponds to each letter in the word. So 1, 2, 3, 4. And then when it's doing like first J minus 1, it's getting the index and basically turning that letter and comparing it to the corresponding letter in the second word. Seeing if they match.
So if they match, in the matrix, that coordinate,
So this seems like an IRB thing. So let's. So if we say first, let's use real numbers here. So on the first instance, we get true, right? And that makes sense because W
Yeah.
equals W.
Mm-hmm.
Yeah.
So this matrix part. So now we're on line 14, and we're looking at matrix. We're trying to, I guess, assign. It looks like we're trying to assign the words or the letters in each word.
Oh, okay. Something just clicked inside of me.
Okay.
So the matrix itself, on line 8, what you have right there is just the first line. And
Yes.
so if you continue it through, it actually goes from 1 to 4. So I'm trying to make sense of line 14 and why you make it equal to I minus 1, J minus 1 right there on the matrix. And what you're ultimately trying to find is the distance. So if there's a mismatch in that certain row, you want to add 1 because there's that many non-similarities or differences in the words.
Right. Does everyone get what Jeremy just said?
Not really.
Can you explain that again, Jeremy?
Yeah, sure. So if you have, wait a minute, is that right? J, I think so. So you're trying to do a hit or miss type of matrix right here. Oh, that's backwards. Okay, well, screw it. I'll put it in a link really quickly. I know I found this earlier. There's a matrix that you have with the first column being the numbers 1 to 4, and then all the other rows, elements in the rows of that matrix are 0. So you want to change that to the... Oh wait, how does this work? I don't know what I'm talking about right now and how we're traversing this matrix.
Okay, so I printed out what matrix is equal to. So it's an array of arrays.
Oh, that's different than what I had in my mind. Okay. Okay, so again on the logic on 13, if the letter of the first word and the letter of the second word are equal to each other, then change that matrix into the value of the diagonal one to the top left. Wait. See, so if that's the first letter and the first letter, then we're on the that second row right there in that matrix, and that second element. So it's the 0 next to the 1 right there. Yeah, I got it. And so that changes to a 0. So this is easier if you draw a grid.
Yeah, hold on. Let me, so what are we looking at? So we're looking at I equal to starting at 1, right?
Mm-hmm.
And we're looking at J starting at 1. So that's, right, so this should be this 0 that you just mentioned. Then we're looking at 0 and 0, right? And that should just be that 0 that at the beginning.
Mm-hmm.
Okay.
So basically all they're saying is make this 0 equal 0. So it's 0 equals 0.
And then it moves on to the next one. So then it moves on to the second letter of the first one, comparing it to the first one still. So it's comparing the W to the O.
Okay.
So because that's an else case, so this would be matrix 1, 2. Let's see. That would actually equal. Oh God, there's so much stuff here.
Here, do you actually want to share your screen?
Sure. Entire screen share. Let's see. Want Sublime open? Which one is this one? We're looking at. That's the wrong one. We're looking at this guy, right? Just put it in there for now. Okay, so everybody can see mine, or
No.
Yeah.
Oh, yes.
okay.
Oops.
Oh wait, I'm not broadcasting mine. This is hard to do two things at once.
I can stack yours.
Okay. Oh, you can do that? Awesome. Okay.
I wonder if we just each gonna mute until we start talking and we just switch back because the screen keeps jumping back and forth. It's very hard to follow.
Okay. Yeah, you can do that. For sure.
You can also click on the picture at the bottom and it won't jump anymore. Like if you click on Jeremy's square at the bottom.
Let's see.
It's working.
Okay, so it gives us 3 cases. And then it tries to find the minimum of these 3 numbers right here. And then we add 1 to it. Oh, I can't hear any. Oh, okay. So everybody muted themselves right now?
I didn't.
Oh, okay. Hi, Mare. So let's see. If we did this in a grid style, this would be 1, 0, 0, 0, 0, 2, 0, 0, 0, 0. I did that wrong. 1, 2, 3. Is that right?
Yeah.
I think I did one too many numbers here.
Nope, you were
No?
right.
I was right. Okay. So then we're going through each one of these numbers, basically. Wait, am I missing a 4? See that? No.
Yeah, that's 4. Yeah, I think that's good.
I feel like I'm wrong with that. Okay, so this is going through comparing every. This one's comparing the W to every letter in the second word. So then, okay, this one, right? Because this is 0, we just explained that one. This one is. This one splits into 3 things. So if we do matrix 1, 2, for example, we're going to get 3 different matrices. Let's see. We're going to get I minus 1 and j. So that's, let's see, so I minus 1, I is row, I is going up right here, and j would be 2. So that would be 2. I would be the same row. J minus 1 would be 0 right there, because you're going 1 to the left, if that's j. Am I traversing this right? And then I minus 1, j minus 1, that's the diagonal, so that's the 1, that's 1 right there. So then you take the minimum of all 3 of those, that would be 0, and then you add 1 to it. So this would turn into 1, because you would need 1 substitution, or something like that.
Yeah, that seems right.
And then you continue doing that through all the letters. And so you do it row by row, and this will, every row changes with how this row, the last row, changed. And then finally, you return the very last value right here, and I don't know why, but that will give you the minimum. Okay, that's all I got.
So Jeremy, if you go back to your sublime, so the last element, so on the last line, on line 27, the last number would be a 1.
This would be a 1. Okay.
So then we're calling dot last because it's a 2-dimensional array.
Mm-hmm.
And then once we do that, we get the distance between the 2 words.
Mm.
So in this case, it was a distance of 1 because it's just one substitution.
Okay. So let me see if I fill this out correctly. This one would be 2, and this one would be 3. If you go to this one's a minimum of 1, 1, 1, 1, 1. I don't know if this is making any sense to anybody, but basically, you're looking at three numbers here. You're looking, I'm looking at this element right here, and I know this element is not the same letter. Then it's going to look at these 3 numbers right here, this 1, this 2, and this 3, and it's going to find the lowest number there, and it's going to add it by 1. So that would be a 2. This one would be a 2. This one would be a 0 because, no? Is it? No, this one would be a 1. Oh, so okay, I see that now. Because it found that this was the minimum number on this if matrix right here. And it passes that down because it knows it needs 1 substitution at least. So this matrix shows how you could do it with the path. I don't know if that made any sense to anybody, but it clicks with me when the lengths are the same, but when the lengths are different, how does that work?
Well, we could try.
Okay.
So you gave the example of if we had like just an extra Y on the last word. So instead of word, it was word.
No. P. Okay. No. I thought that was gonna turn into a grid mode. So this is the same. Okay. I don't know how to. I don't know where my file is. Is that bad? Okay, I put in my downloads. Okay, got it. CD. Ruby lev.rb. Okay. Oh, I thought that was gonna work. Okay, well.
So we have something similar. We have how many? 1, 2.
Oh crap. This is what we get right here. This grid.
Right.
Oh, okay. That makes sense to me. So because each one of these characters, so if we started with this one, 1, 2, 3, 4, they're all the same character until the last one that adds a 1 to it. Okay, that makes sense.
Do you guys have any questions? I know we're all trying to just go through it together, but do you guys want to think out loud? Can you guys unmute if you have some?
Jeremy, could you put up that screen again? I'd like to see those the matrix.
Oh, wait. So any questions, Lena?
Oh, yeah. Okay. I think I'm getting it.
I think the one thing I'm understanding a little bit better is like how the path kind of works in a way. It's just trying to find the path of least substitutions. So if like the first letter was off, then you know you need at least one substitution because that. I don't know what I'm trying to say here. I'm like slightly confused, yet slightly get it.
Yeah, that's where I'm at too.
Let's see. Well, I found another implementation of this. I don't know if it helps. Nope, that doesn't help me. I'm looking at it.
Jeremy, are you looking at the JavaScript one?
No, I'm looking at this on Rosetta code. Let's see. I will put it on the chat. It's been whatchamacallit, refactored down, and I'm pretty sure it's going to take another few minutes to actually look through.
Yeah, there's a recursive solution too. on the Wikipedia.
Okay. Oh, okay. Oh, this is gonna help a lot. As in, this will take like a while to look at and then have it explained. So I'm putting another link in here. I'm gonna. Can I stop presenting right now, or? I'm just gonna stop. And then I'm gonna do that. There we go. So if I read this, it says the Levenshtein algorithm, also called the edit distance, calculates the least number of edits operations that are necessary to modify one string to obtain another string. The most common way of calculating this is by the dynamic programming approach. A matrix is initialized measuring the in the MN cell the Levenshtein distance between the M character prefix and, okay, reading this doesn't help me. That's allowed. But basically, you're trying to draw a path to get from one corner, the top left corner of the matrix, to the bottom right of the matrix. So
that's why you you get a number for each combination, because you don't know which path it's going to take on the next line.
Yeah.
Kind of. Yeah.
I'm supposed to present to everyone. Did everybody catch what Joe's trying to say? Oh, Jen, your mic's.
Sorry, Joe, can you repeat that one more time?
Yeah, sure. Like, the way I understand it is, like, you go through all the letter combinations for, like, the first letter of the first word.
Okay.
Because I guess, like, you don't know which path it's going to take. I feel like I explained it better the first time, but like, you're trying to create a diagonal path, but you don't know which cell in the matrix it's going to start off of, kind of, or go off of.
I'll put up the grid again. So in the grid, you're starting from the top left corner and going to the bottom right corner, and you're trying to find that path that takes you to the least number of substitutions, insertions, or deletions. So in the anagram on the bottom, or the anagram looking thing, what is it trying to show you? It's trying to show you where it's going to need substitutions, insertions, and deletions, and which one's the most least costly one. Wow, I did explain that not as good as the first time, I think.
So it's basically finding the least costly combination on each combination.
Yeah,
and that's your path.
Yeah. So you mean like by the least costly combination is just from going from the left to the right, one by one?
Oh, right. No one can see me nodding my head. Yeah, that's
yeah.
pretty much, yeah. Marek looks a little bit he looks like he's thinking. We can't hear you. I'll just unmute him.
Yeah, I said I'm thinking. You're right.
Well, I don't know if I can bring us to a little side tangent, but I found a Ruby implementation of this, but I realized most of it was written in C, so that kind of got me down a stupid rabbit hole of looking at native extensions and stuff like that. So you can write C code and kind of integrate it in. So this person wrote C code for their version of Levenshtein, and then integrated it with Ruby to make a gem for it. So there's a Ruby gem out there for it, but it's really hard to read if you don't know anything in C. I somewhat do, but I'm really rusty at it. So yeah.
So I feel like each of us kind of get the basics of what's happening. I think that probably the best way for each of us to understand it on our own is probably to play around with it in IRB.
Yeah, that sounds pretty good.
Yeah?
Yeah, I agree.
Yeah.
Okay, because it's kind of hard to like go through like a loop of a loop just like looking at it. So.
Yeah.
That sounds good. I think this is a good stopping point right here.
Yeah.
Oh wait, let me stop presenting. That. So I have a question for you guys.
Yeah.
Well, this is not for Jen because she chose this week, but does anybody want to kind of tackle code for next week?
I can do next week's.
Okay. That sounds great.
I don't have an idea yet, but I'll figure something out and I'll email you.
That's awesome. All right. Cool.
Okay.
All right,
That's all I
Jeremy,
have.
I'm gonna send you a quick note
Okay. Yeah. Sure.
about the recording and stuff. So I don't.
Yeah,
does
sure.
it go up straight? Like, does it automatically go to YouTube?
You know, I think it does. So I'm also certain that I can edit some of this stuff.
Okay.
But I'll tell you quickly, and I'll remove it if you don't want me to put it up.
Yeah. Here, I'll.
So it's up under what? Are you gonna send out the link?
I think you get the link automatically for being invited to this hangout. I don't know. I have never played around with Google Hangouts on air before, and I'm almost certain that other people can view us publicly. Oh, okay, yeah. I will totally. I got it, Jen.
Thanks.
So I'll totally go through it and make sure that it doesn't do anything. I will completely remove the video if I can't figure it out.
Okay. Cool.
Alrighty.
Cool.
All right. So other than that, is everyone doing okay? In terms of, like,
I'm gonna stop the recording right now.
yes.
Okay.